Let me start by reviewing manual memory management, the thing I want you to stop doing. In a nutshell, it comes down to the rule that whatever you create on the free store with new, you have to take off the free store with delete. Back in the days of C, whatever we created with malloc, we had to release with free. So in C++, whatever you knew, you must delete. And if you knew an array with square brackets, then you had to remember to delete with square brackets. And if you forgot, you would get a memory leak. C++ gave us the idea of writing destructors, so that I would have an object that would contain a pointer, and when that solid object was destructed, it would call delete on the pointer. Of course, if you make a copy of the solid object, it contains a copy of the pointer. When the copy goes away, it deletes on the pointer, and now the original has an invalid or dangling pointer. So we go and we write copy constructors and copy assignment operators. These are often referred to as the rule of three. If you feel that you need to write one of destructor, copy constructor, or copy assignment operator, then you need to write all three. And you know what? It's hard. It's just hard. That's all there is to it. And it's especially hard if you're dealing with base and derived classes. One of the reasons that it's hard is that it really forces you to surface who owns what, and make that very clear in the way that you're writing the class. Unfortunately, once you've made those decisions, you're not really showing anyone else what those decisions are. So I have a snip of code here where A has a member function, set something pointer. It takes some pointer B. Someone's going to call delete on B eventually. But who? Is that something that A is going to do now that it's keeping that pointer inside itself? When the A goes away, it'll call delete on the pointer? Or is it just keeping that pointer to use when it needs to talk to the other object and it's expecting someone else to do the cleaning up? You cannot tell by reading this code. And so the developer has to write an awful lot of really kind of boilerplate stuff, and then people who are consuming that boilerplate don't always know how it works. This is the old way. It's hard, it's not expressive, and it's easy to get wrong. When you get it wrong, your applications either crash because they're trying to use memory that's been taken over by someone else, or they leak. And those are both bad. If you think that memory leaks don't matter in today's applications, I have an application that I use every day. If it didn't have a memory leak, it would just be up all the time on my laptop. But because it has a memory leak that the developers know about but haven't been able to trace down, I have to close it once or twice a day and then restart it because it gets up to such a large working set that it actually makes the rest of my machine not so responsive. Memory leaks are a real problem today. And remembering to delete whatever you knew is not the solution to memory leaks. What is? I'll show you.